Hello, my name is Frank, and today I have choose the three topics, and I will explain and analyze it. The three topics are DLT and consensus mechanism, and socio-economic impact of cryptocurrency. I will explain the reason why I choose these three topics one by one. So for the first, DLT. The DLT, the reason why I choose this, because it's kind of interesting. In an era where the data has become paramount, safeguarding its integrity has taken precedence. Distributed ledger technology, which is DLT, originating as a technological marvel in the Bitcoin white paper by the enigmatic Satoshi Nakamoto. Demonstrates pivotal shift from centralized to decentralized data management, reducing risk of data tampering and providing a transparent, immutable ledger across multiple nodes. Now I will talk about the unfolds the relevance mechanism, application and challenges and future potential for the DLT. For the first, the historical context and the development of DLT. In 2008, a pseudonymous entity, Satoshi Nakamoto, introduced Bitcoin, providing the first practical solution to the double spending problem in the decentralized network without the need for trusted central authority. Nakamoto's innovative foundation was DLT, which underpins the Bitcoin and functions as a decentralized database, consistently validating and recording all transactions across numerous participants. Well, initially entwined with cryptocurrency, DLT has evolved, finding diverse applications across various domains, encapsulating the benefits to decentralization, transparency, and security in data management. The core mechanism of DLT is decentralization stands paramount in understanding of DLT. Traditional system consolidates data control and management to the singular entity, rendering it susceptible to malicious alterations and single points of failure. DLT decentralizes this control, dispersing the data crossing numerous nodes, ensuring no singular points of control or failure. An essential characteristic of DLT is immutability, where the data once recorded is virtually impossible to alter. Cryptographic hashing plays a pivotal role in this, encoding transaction data into a fixed size, preventing retroactive data alterations without altering all subsequent data blocks, which is computationally impractical. Despite its immutability, DLT provides a transparent yet data network. All transaction data are visible to all network participants, ensuring transparency, while pseudonymity is maintained as user identities are concealed behind cryptographic address. For the applications and use case of DLT, DLT's application transcends its initial cryptocurrency realms. With cryptocurrencies like Bitcoin, DLT provides a secure and transparent mechanism to validate and record peer-to-peer transactions without intermediary intervention. A pivotal innovation has been smart contracts, which are self-executing contracts coded with predefined rules and consequences, executed automatically upon condition. Fulfillment Ethereum, a DLT platform, facilitates these smart contracts, paving the way for decentralized applications. DLT finds the valuable application in supply chain management, ensuring a transparent, immutable, and traceable record of product life cycle, from production to delivery. In healthcare, DLT provides potential solution for secure and interoperable management of patient data. Also, there are some challenge and limitation of the DLT. Despite its prowess, DLT faces challenges like scalability and widespread adoption. Scalability concerns particularly in transaction throughput and energy efficiency when compared to centralized alternatives. Bitcoin, for instance, faces criticism for its energy-intensive proof of work, consensus mechanism, and limited transaction throughput. The adoption of DLT faces hurdles in technological complexity, lack of regulatory clarity, and incidents like the DAO hack, which exposes vulnerability in smart contracts, highlighting potential security and financial risk involved. Future implications and conclusion. DLT's future ushers in the possibility of interoperable blockchains, further scalability, and enhanced energy efficiency. Innovations and research within DLT continue to burgeon, exploring solutions for present challenges and expanding its applicative domains. The next topic, I will talk about consensus mechanism. The reason I choose this topic, because it's in the world of the decentralized network and the quest for maintaining order and agreement without centralized authority become evident. Consensus mechanism become the linchpin enabling a decentralized system to agree on a single version of truth. This dispute being operated by married nodes with potential conflicting interests. Now I will be talking about the understanding consensus mechanism and type of consensus mechanism and the challenges and limited and the future of it. For understanding consensus mechanism, it is the heartbeat of the decentralized network, providing a pathway to achieve agreement among distributed nodes, from validating transaction to maintain network security. They facilitate decentralized decision making, thereby preventing double spending, ensuring that each transaction is valid and agreed upon by a majority. In the absence of centralized authority, this mechanism offer democratic and systematic approach toward data validation, ensuring that every node has an equal say in the decision-making process, and that malicious actors cannot manipulate the system with ease. For the types of consensus mechanism, I will explain easily one by one. So the first one is proof of work, which people call POW, which is employed by Bitcoin. It requires nodes or miners to solve the complex mathematical problem, ensuring security and agreement through the computational efforts. For the POS, proof of stake, outlaced by Ethereum 2.0, it entails validators being chosen to create new blocks based on the number of coins they hold and are willing to stake as collateral. For DPoS, it imbues democratic tint, where network participants vote for a few nodes to be validators, streamlining efficiency at the potential cost of decentralization. For the POA, funding networks like VeChain, POA confers the validation authority upon nodes that have verified identity and are trusted by the network. For the challenges of embedding consensus mechanism, despite their I will just say one by one. For the POW, well secure and decentralized, is often criticized for its extensive energy consumption and limited scalability. For the POS and the DPoS, well scalable and potentially more energy efficient, raise questions concerning decentralization and equitable participants. For POA, it's scalable and energy efficient, can arguably consolidate control in the hands of verified authority, potentially eroding trust in the network. For the charting the future pathway, navigating forward, consensus mechanism stands at a crossroads, necessitating innovations that can harmonize scalability, security, and decentralization. Layer 2 solutions, sharding and hybrid consensus mechanism are amongst the innovations that aspire to mitigate existing challenges and foster secure, scalable, and decentralized future. For the third one, socioeconomic impact of cryptocurrency. I will talk about financial valuation, socio-cultural implications, global and ethical considerations, and a path forward, which is the future. The reason I chose this topic is nestled within the Nexus technology of finance and finance. Cryptocurrency's emergence not merely as a digital asset, but also as a socio-economic marvel, threading a complex weave through the financial markets, societies, and global economies. Cryptocurrency, with its decentralized, borderless, and digital nature, embark on the journey through the socio-economic landscapes, influencing, distributing, and reshaping them. For the economic impact, for the financial ripple, financial inclusion is cryptocurrencies have the potential to augment financial inclusion, providing unbanked population with the access to financial services through mobile technology, thereby fostering personal economic growth and reducing poverty. Market volatility. The volatile is nature of cryptocurrency prices, driven by speculative trading, presents both opportunities and risk with the financial markets. Where trades might reap profits, the volatility also cultivates risk and instability in the economic ecosystem. Impact on the traditional finance. The essence of decentralized financial, which is DeFi, disrupts traditional banking and financial services, providing alternative solution for lending, borrowing, and trading through the decentralized platform, thereby challenging the conventional financial structure and intermediaries. For the socio-cultural impact, unveiling the new social tapestry. With distribution, the advent of cryptocurrency has engineered a new pathway for the wealth generation and the distribution. Early adopters and the investors, such as Bitcoin millionaires, depict reshaping of wealth distribution. We're also eliciting this discuss about the economic disparities, privacy, and autonomy. Cryptocurrencies empowers individuals with financial autonomy and privacy, enabling transaction without the scrutiny of centralized entity, thereby fostering a new financial liberty, but also spawning debates around the legality and ethicality of transactions. Community and culture. cryptocurrencies has birthed a robust community and culture. Intervening technologies, investors, and associates bound by a shared belief in decentralization and blockchain technology, shaping socio-cultural narratives for the global impact, reshaping international relations, cross-border transactions. Cryptocurrencies facilitate cross-border transactions, diminishing barriers erased by currency conversion. The decentralized and global nature of cryptocurrencies pose challenges to international politics and regulations, prompting collaborations and consultation amongst nations in craft regulatory framework and policies. And this is my presentation. Thank you for listening.